All I can do is provide the resource. It's up to the students to use it. All right, so now let's do this one together, okay? And then we'll clear these off, and then we're going to copy these in our notes, and then we're going to do some more. All right, more practice problems, and you're going to learn one more new thing today. That's it, and we're just going to practice. All right. So if we count the longest chain of connected carbons, or how'd you say the longest carbons in a row, or yeah, something like that. Okay, now whatever makes sense. Good. What's the longest chain here? So when you start counting, what's the biggest number you get up to? 4, right? 1, 2, 3, 4. Or we can take a turn. 1, 2, 3, 4. Or we can start here and go 1, 2, 3, 4. It doesn't matter. Or we can go 1, 2, 3, 4. Or we go 1, 2, 3, 4. It doesn't matter. The point is, it doesn't matter because 4 is the longest chain. I always keep it simple. I want you to do the same thing. Don't use this. That's just weird. Keep it straight. Straight chain. Straight chain alkane. And what do you call these things that come off of it?
Branches.
Branches. So this is a branched alkane. These would be straight chain alkenes. No branches. I'll give you one example of a branch coming off of these later, but it's really uncommon. The branches are pretty much just alkanes. All right, so now we box that, we circle this, and circle this. This is new today. We have 2 branches, one going up, one going down. So we have 2 branches. All right. So now, next part of the naming process, what do we name first?
The box.
The box. All right, 4 carbons. What's that?
Bute.
All single bonds, butane. So inside the box is butane. Outside the box, I have a CH3 here, I have a CH3 here. What do you call that? It's the same thing as this. It's a methyl. What do you call this? Same thing as this. Methyl. So I have 2 methyls, one branching off one side, kind of like 2 arms. One going this way, one going this way. They're the same thing. They're the same thing. So that would be like if I put, give me a second. So if I put this here. All right, that's exactly what that is right there. That's the same thing. So you got the 4 in the middle, that's your main chain, your parent chain, carbon backbone, all those names. And then you got your branches, this one coming down, this one going up. So these 2 are identical, they're both the same thing, both are methyl groups. All right, so now what's next before we name it? We have to number it. Go for the low. Well, there's 2 groups. So there's only one way you can number this thing. 1, 2, 3, 4, or 1, 2, 3, 4. It's literally the same thing. Whether I hold this molecule like this, or if I spin it like this, it's literally the exact same thing. So both methyl groups, this one and this one, are on the 2nd and 3rd carbon. Doesn't matter if you number it from left to right or right to left. So in other words, if this is the 2nd and that's the 3rd, or if this is the 2nd, that's the 3rd, doesn't matter. They're the exact same thing. Does anyone think they can name that? 2. I don't have any ethyls.
2.
2, 3. I like that. 2, 3.
Methyl butane.
Close. You're so close. How many methyls are there?
2 methyl
2 of them.
butane.
So you're going to learn something new here. What's a prefix for 2? Close. The other one.
S.
Di. 2, 3. Dimethyl butane. Write that down. Or you don't have to because you're going to write it in your notes, so you can actually clear those off. You can put those back. Take out your notes. We're going to copy these down. I'm going to explain that one again because I know that's probably confusing. And then we're going to do some more.
I'm so tired. Shoot.
Okay, so in your notes, we're just going to pick up where we left off yesterday. Just copy all these down. It doesn't have to look the same as the board. You can put them all in a row. However you want to write it in your notes, but write this down with the name. Write this one down with the name. Put these 2 down with the names. I'll give you a little time to do that. It's just good practice to write this stuff down. Plus, tomorrow when you're doing the worksheets, you can look in your notes for help. I think I'll probably have you guys work for most of the period by yourself, and then the last maybe 10 minutes you can pair up and kind of compare some answers. Maybe the last 15 minutes, so about 20 minutes on your own, 15 minutes-ish. Pairing up. And yeah, I may actually just give you the worksheets today. You can just bring them tomorrow. That would be easier. Just leave them here. It looks like a lot, but some of these will be a lot easier than others. So Salem has lab. She's not here. So is Talia. She has lab later. She'll be in lab. What do we do? Starting a new lab.
Day before break.
Mm-hmm. Let's do it. Well, it's 2 days before break time.
Yeah, but we don't know what happened.
Who's that? Well, tomorrow.
Yeah.
Yeah, we don't have lab, so gotta start it. I love starting a lab before break.
Why?
We all forget it.
So when we get back, we don't have to start one. We've already started it. It's easier from a teacher's perspective. I don't have to like scramble to get things ready. We're already rolling. That doesn't really make a difference to you guys.
Forget the information either way.
Right, that's what I mean. So it doesn't really matter to you guys, and it's just easier that I have everything kind of going before we. Except with the AP. The AP, we were gonna start one, but the chemicals will go bad, so I gotta wait. It's kind of annoying.
Kind of annoying.
Okay, so can I erase number 1? I'll take that as yes. What about number 3?
Did you see that whole cyberbullying presentation, or were you up here?
I stayed up here. I was gonna go, but then I decided not to. I had a bunch of. I had to clean up lab. I got it all cleaned up. Again, I can't let stuff sit over break, so I used to time to do that. But was it good? Was he just talking about like I don't know what word it is, but like the pitfall or what like the thing kids kind of like fall for? So like the next thing you know, they're in a bad situation.
Yeah. Peer pressure, all that stuff.
Yeah, I mean it's scary. Scary because that when I was your age there was internet, but it's not the same, and it's but it just was starting to. It's funny, as soon as the internet became a thing, these dirtbags were on there trying to like seduce kids. Like it was like immediate. It was
That's
like a
crazy.
problem immediately, and now it's exponentially worse now. And people will say, is society getting worse? Like where are all these people coming from? And I think way before the internet, they just didn't have a way to contact kids, and now it's like an easy way. So now it seems like there's more messed up people now than 20 years ago, but I don't think that's the case. I think it's just easier because they have access and they have these devices. And it's really sad and scary. You guys are old enough, I would like to think, to kind of know what's going on, but it's the younger ones, like middle school, they don't really know what's going on. So that it's really more dangerous for them. But I'm glad you did that. I thought that was a good thing. Did you like learn anything new or?
He just basically told us to like watch out. He showed us videos and stuff like that, and talked about the actual laws that can come into play and
Yeah.
stuff like that. He did good.
Good. Yeah. I mean, it's crazy. It's scary. It's scary to me, and my daughter's still really young, but 10 years from now, I don't know. Can't even think about that. It's scary. All right.
Pop him a
We're
cool.
good? Oh yeah, I don't even want to talk about that because I'm already getting my adrenaline's pumping right now thinking about it. All right, so now Now back to this. So this was new. Why was it new? Because there's two substituents. So the only thing I want you to understand about this is if you have two of them, you have to write di, because di means two. The only other thing is the number. This one is 3, this one is 2. So the rules still are the same. You find the longest chain, box it, circle everything outside, number it, go for the low. But now you just need to remember each one gets a number, so 2 and 3, and then di. And this is kind of what Bella was asking earlier. You know, if I don't write it exactly the same, does it still count? If you wrote 2,3-methylbutane, I'd probably give it to you. If you left off the 2,3 and wrote dimethyl, I wouldn't. The numbers are more important. It's just going to take practice. So let's do a couple more.
Can there be a branch on a branch?
Branch on a branch? Sort of. We're going to see that right now.
Can there be more than 2 branches?
There can be more than 2 branches. What's the prefix for 3?
Try.
Try. All right. Good.
Then how would you go from to go for the low and then if there's 3?
Right. I'll show you one. Okay. Here we go. Write this down. One more substituent called an ethyl group. Ethyl group. An ethyl group is CH2CH3, or the way you're going to see it most of the time is this way. These are pretty uncommon. If you're good with the methyl groups, then that's probably good enough. But I got to at least teach this one. So what is an ethyl group? It's when you have 2 carbons hanging off. So there's 2 carbons that are connected. 2 carbons that are connected is an ethyl group. That example I just had up here, they were 2 separate carbons, so that's 2 methyl groups. If they're together, so this here is an ethyl group. What's going on over there?
She's eating your blueberries.
Talking about blueberries?
I have
Okay.
blueberries.
Blueberries are good. Okay, that's an ethyl group. So you have 2 carbons, so this would be like connected to like a long chain of carbons. So imagine you had like a whole chain, like 7 carbons, and this is branching off. So you have your trunk, and then that's an ethyl group. This is methyl, right? 1 is methyl, 2 is ethyl. So, let me give you an example of this. So if we have 1, 2, 3, 4, let's say 5 carbons. On the middle one here, the 3rd carbon, we're going to have 2 C's that go down like this. So go ahead and copy this down. By the way, you see that I'm not labeling H's on a regents. You also do not have to label H's. I always cringe a little bit when I tell kids this because kids will stop writing H's because that saves a lot of time. But then eventually what they'll do is they'll get real lazy and they'll stop putting the dashes. If you do that, you won't get credit on a regents. So, in other words, this same exact structure, like that's correct. If you were to draw this, no credit. You have to show your bonds that are coming off. You need 4 lines per carbon. So you have to show these. You don't have to write the H, but you have to show the dashes or the bonds. Okay, again, I cringe because, you know, that phrase, you give somebody an inch, they take a mile. You know that phrase?
Mm-hmm.
Good. That's kind of what happens. Kids are like, oh, I don't have to write the H's, and then somehow in their head they get to the point, I don't have to write the lines. Yes, you do. You have to write the lines. All right. So, let's name this. What's the longest chain of connected carbons? 5.
Or, wait, 1, 2, 3.
Right. So even if I took a right turn, it's still 5. 1, 2, 3, 4, 5. If you, so this is going to sound real ridiculous, but if you name it right, you're naming it right. So there's always more than one way to kind of make your box, but it doesn't matter. So if you're doing it right, it's right. It doesn't matter which way you do it. All right. So what's the name of the box?
Pentane.
Pentane. What do we do with everything outside the box?
Circle.
Circle it. That is an ethyl group. That is an ethyl group. Just to be clear, on the board, just so we're all looking at the same thing here, this is what I had as the warm-up and what you just copied in your notes. This is butane in the box. This is a methyl. This is another separate methyl. Meth means 1. there's only one carbon. There's only one carbon. So this structure has two methyl groups. This structure has one ethyl because they're connected. It probably makes sense when I spell it out, but on worksheets, homework, whatever, lab, you might get confused. I get it. It's why we practice. Just try and keep that straight. Meth means one. So one carbon is methyl. Even though there's two of them, it doesn't add up to an ethyl. It's just two methyls. This is how ethyls look. And again, this is pretty rare. This structure would be pretty common, I would say, in Regents. This one, not. Okay. All right, so anyways, we only have one more thing to do. Number it. It's got to be 3. Doesn't matter which way, right? 1, 2, 3 or 1, 2, 3. So now we put it together. This is 3-ethyl pentane. 3-ethyl pentane.
How are they going to ask a question like this on the Regents? Like, name this structure?
Yep. Yep. They actually, so there's a few ways they could ask. Reagan said, how would they ask this? Multiple choice. They could say, which of the following structures matches the name 3-ethyl pentane? So they'll give you 4 pictures, essentially. Or they might say, short answer, draw 3-ethyl pentane. That's harder, I think, than a multiple choice. Or they may give this structure as the question, and then the multiple choice might be 4 names. So that's kind of the 3 ways they would ask that. Or, I guess it could be a short answer. They could give you a picture of it, structure, and then they say, what is the name? What is the IUPAC name? That's the IUPAC.
The IUP, I see it.
So, if you guys see this on Regents, which makes me like crazy, I want to rip it up. This is just kind of like the governing body of the chemistry people who say, this is how you name that structure. The box, the numbering, the circles, the way I teach it is the way this organization tells me to teach it. So on a Regents, it might give you this structure and say, which of the following IUPAC names is correct? Don't let that freak you out. That means absolutely nothing to you. You've learned everything you need to know, so don't let that, worry you. It stands for International Union of Pure Applied Chemists. That was fun. Moving on. All right. I'm going to draw another one on the board. I want you to name it. Draw it and name it. And then the last 6-7 minutes, I'm going to write some names on the board, and I want you to draw them. So we'll practice that. And then tomorrow you're doing both. You're naming and drawing tomorrow. Some of these should be easy for you guys. I
I
hope.
just want the name, not like the phone number.
Actually, yeah, I'm glad you reminded me. There was something else I want to show you, and we'll talk about that. Yeah, you can write the formula. You mean the molecular formula?
Yeah.
Yeah. Yeah. Actually, that's good. I'm glad you reminded me. That. So there's no branches, right? Straight chain. What class of hydrocarbon is it? Alkyne. How do we know?
Because it has
Triple bond, right. 3 carbons. Meth, eth, prop. YNE. But, you just learned in the warm-up, you got to put a number in front to tell me where the triple bond is. So what's the answer?
2.
1.
Oh, going that way.
Go for the low, right? It's between number 1 and 2. Now I know why you guys said 2, because you started here. 1, 2, 3. Remember, these things actually exist. They can flip, twist, move around. So that's technically 1. So 1, 2, so 1 proton. Okay. Now, I want you to do this in your notes. I want to spell this out for you. Molecular formula. Oops. Put that in the left. Next to it, put structural formula. That's supposed to say formula. And then next to that, I want you to write condensed formula. So condensed formula is something the worksheets are going to show you, so I'm going to explain what that means right now. All right, so let's say I give you the molecular formula C5H12. Now the structures, depending on how big you guys write, I hope you can squeeze it in here. If not, I don't know, figure it out. 1, 2, 3, 4 with a C down here. So we did this a few times already. That's 2-methylbutane. I'm not showing you this to practice naming this. I'm showing you because I want you to see the 3 different ways you could see the same thing. C5H12 is the same thing as this structure. There's 5 carbons, 12 hydrogens. The condensed formula. Let me just draw it and then explain. So go ahead and copy it down, and then we'll make sense of everything, and then we'll practice drawing from a name, at least one example, maybe 2. So the reason I'm doing this is you need to know the difference between molecular, structural, and condensed. Now the regents will pretty much only ask for structural. They want to know if you can draw it, but sometimes this is on there. In other words, if you see a structure like this, I don't want you completely freaked out. Like, what is that? I've never seen that. So the worksheets show you that. I talk about it in notes a little bit. Lab, not so much. Lab, we're doing this. So molecular formula, what is that? That's kind of like where you just count up all your C's and H's, and then that's the formula, C5H12. All 3 of these have 5 C's, 12 H's. They're alkenes. What's the difference between this one and this one? Don't tell me this is condensed.
It doesn't show the bonds, it just says it.
Good. What bonds does it show?
The H's. Carbons. Whatever.
Yeah. So these here, so here if I have a different color, I don't know how well this works, but this, yeah, okay.
The purple ones work.
You can make it out. So those, really? Whatever, because if I start circling more, it's going to get crazy. The carbon-carbon bonds, a better way to kind of show that, is any bond between 2 black ones, that's what is still shown. The black-yellow, those are not. That's what's condensed. So this CH3 is the same thing as this. This CH3 is the same thing as that. This is a CH2, there's your CH2, that's a CH, and then there's a CH3. So it's taking the same structure and not showing the carbon-hydrogen bonds. So it's literally the same thing, 2-methylbutane. All right, so I want to at least show you so you're aware of what the heck that is. All right, let's try and draw one. I'll give you a name, see how you do. And then that'll be it probably.
Draw the condensed formula or the structural?
I'm going to do structural. I don't really do a whole lot of condensed business. Here we go. So here's the name. Let's go 3,3-dimethylhexane. All right. If you can name this, draw this, you'll be a chemistry champion. The trophy will be a Bunsen burner. I haven't taught you how to do this in reverse, but usually once you learn how to name them, you can kind of just figure it out. But that's not something I always have to spell out. I'll go over it, but usually, and from what I see, you're on the right path. One piece of advice I can give you is you better have 8 carbons, because there's 6 here, hex, and then dimethyl means 2 methyls, so that's 2 C's. So that's 8 carbons total. So you should have 8. Hopefully you put them in the right arrangement. And again, tomorrow you're just doing more of this.
Oh, yeah, I didn't teach isomers yet. Yeah.
Alright, we're almost out of time. What do we do? How many carbons in a straight chain?
6.
6. 1, 2, 3, 4, 5, 6. There's my hexane. I always do this. Like if I'm actually answering this, I always do that. I always put in all my bonds so I don't forget. What's this mean?
The third one and on the right. The third one.
So
two of
1,
them.
2, 3.
Yeah. And you
What,
put
what's
it
branched off?
a carbon.
A carbon. Good. That's one methyl.
And then go
This is a tricky one.
3 from the right.
Yeah.
Ah,
Yes.
man.
That's correct.
I thought it was that, but I was
Got it.
So wait, real quick. So fix it, but look here, real quick. What carbon, hold on, give me 10 seconds. What carbon is that? It's not 3, it's 4. If that's 3, that can't be 3 as well. So that's how it looks. Alright, so you'll be practicing that tomorrow. You know what? I'm not gonna give you the worksheets.